incubation is visibility, right?
Yeah, right.
There's like 79 repos in there of varying quality,
Yeah.
right?
Okay. Yeah. No, this sounds good to me. So, I mean, realistically, we are not going to be able to work on this, on the whole framework and implementing it in this quarter. My hope is that we can finalize the design and the way to implement things in this quarter. And then when it comes to implementation, all those repos and different structure hopefully will be in place next quarter, and we can just start on that.
And regarding framework, I also had comment related to cluster capacity. I don't know whether you got a chance to look into that or not.
Command related to that, what do you mean?
I mean, like when we are thinking about framework, and if we think about use cases like cluster capacity, like where cluster capacity, although like it's not I don't know, like maybe you could call it like maybe virtual scheduler, because it does not really schedule. So basically, it was to be it was to be as close as possible to default scheduler with respect to feature and functionality, but still it wants to override the core function binding because it does not bind.
Right.
And in previous releases, even in the current release in 1.9, because of so much restructuring in the code, it's been painful how to reuse default scheduler code and then to make it for cluster capacity.
Yeah, there'll have to be some policies around. One thing that the Kubernetes as a whole sucks at, and if we're going to create something like an SDK, is that we need to support version compatibility and have promotions and deprecation. That should almost be defined like in the beginning, so the ambiguity isn't there. Because what often has a tendency to happen, if you like walk through, like I just updated my client Go on one of my repos I manage, and it was painful as hell.
Yeah,
Like,
exactly. Yeah.
this is client Go. This is supposed to be the thing that everyone uses, right?
Yeah. For example, let's say like we have default scheduler, and let's say like maybe we have several custom scheduler based on default scheduler. If let's say I run some cluster capacity, how can I make sure that the functionality that is being used by cluster capacity are exactly similar to default scheduler or whatever customer scheduler that is being run in that cluster? How to make sure that how to say confidently that cluster capacity like is really running all the features that are part of the whatever scheduler that is being run in that cluster.
Actually getting the same.
Because then only we can make the analysis as close as possible or as correct as possible.
Right. So I don't think there is any great solution for the problem that you were talking about. I don't know. Maybe you have some ideas, and I'll be happy to hear those. But I feel like, let's say that we have a very simple skeleton for scheduling, and then we have a bunch of plugins, and some of these custom schedulers have pretty fancy plugins. How can a cluster capacity tool as a separate process, which is like completely independent, know about all these plugins? If those custom schedulers are something that, for example, built by a user in a separate environment and that we don't even know about. So
No. I'm not talking about custom scheduler. That is completely different implementation. When I say custom scheduler, and I think that's been one of the reasons like why we are going to a framework. Like it's a default scheduler, but maybe one scheduler might use, let's say like we have 10 features in our scheduler. Maybe in one cluster we are using 8 features out of those 10 features, and maybe in another cluster maybe we are using 7 features out of those 10 features.
right,
And
right.
when we run cluster capacity against those clusters, like we need to make sure like when we are running cluster capacity against the cluster that is using 8 features, cluster capacity is also enabled with those 8 features, and the similar for the
definitely that would be definitely an option. Actually, in fact, it is even an option today. We have this scheduler policy config that either can add or remove some of the extenders, and also add or remove some of the predicate functions, or change priority and their rates and all. So we will definitely have a very similar config for for adding and removing some of these plugins?
Yeah, so as far as like we have something based on like let's say like config file, because right now we also have so many features. Some are alpha, some are enabled based on. I mean, it's really difficult to make sure whether like we are running cluster capacity with all the features that the scheduler is being run. Because how to make sure that the scheduler has really enabled those features and maybe cluster capacity has not enabled those features.
I see. Yeah, so we have a combination of configs today. We have those flags or component configs
Yeah.
and policy config. So yes, I understand that it sometimes becomes a
It's
little
like if we have like let's say like you just have this config file and if you run that your scheduler code, that means you are exactly getting the same features, something like that.
yeah, I see. Yeah, I will definitely keep that in mind. Hopefully, we can achieve that. All right, so sort of like centralized config for the scheduler.
It's like when you look at that config or whatever, like we can say, okay, we are sure like what functionalities really we are using in the cluster and what functionality that scheduler is using.
Okay.
It's like if we have to run two similar scheduler and two different clusters, we are sure they are really running with the same features.
Yeah.
I think that gets back to, I think, a comment, Avesh, that you made earlier, which was that it's difficult to keep like when the code structure changes.
Yeah, exactly.
So probably in part of in part of the effort of making config a better sort of interface or abstraction, we can make running the scheduler more abstract as well, so that cluster capacity would depend on a very small set of the scheduler code just to start it up, and the rest is internal.
Yeah, because when I was doing rebase for 1.9 and even I have seen the previously, like it's been really a painful.
Did you get that working? I tried the same thing.
Yeah, now it's working.
Oh, okay.
Okay, so I guess nobody objects the idea of framework. We need to basically hash out the details. I will write a design doc, hopefully this quarter, and then we can go from there. The next topic that we have is how to add preemption to daemon set controller, or what to do with the daemon set controller scheduling logic. This is a more contentious topic. There has been a lot of comments on the design doc that I wrote, and I have had at least a couple hours of discussions with Brian Grant yesterday and today in the morning about it. So in that document, I proposed like, I guess, 4 different solutions. One of the important ones, which I was thinking about, is to basically remove the whole scheduling logic of the daemon set controller and just let it have the node selectors, and upfront daemon set controller finds the set of nodes that a particular daemon set needs to run and creates pods for all of them, and leave it to the scheduler to do the scheduling, preemption, whatever is needed. That's solution number 1. Solution number 2, I think, in that document is proposed by Yasin, who's not in this meeting, I believe. He was saying that daemon set controller can do preemption and then taints the nodes that it has preempted on, so that no other node can be scheduled on those nodes until the daemon set pods are scheduled there.
So can we pause for a second?
Sure.
Like the preface of all of this, it is based upon a supposition, which I think we need to vet first. Which I don't think there's a bit here that I think is an edge case, and that's what I was trying to allude to in the beginning, which is that for critical pods, you want to have priority on daemon set based critical pods, like the kube proxy is a great example.
Yeah.
Right? That are part of bootstrapping, right? And you eventually want to have the ability to swap those pods with newer versions on upgrades, right?
Sure.
But it's super rare that besides an in-place upgrade, which we should be able to support in daemon sets, but there's actually this weird conundrum that other folks have wanted to put that feature in the daemon sets, where it creates the new one and removes the old one in place. Outside of that, it's very rare to actually have a preemption scenario that you would need for daemon sets, unless they're super packed to the hilt, right? And in those cases, you could also do things like have a reservation, right? If something is so critical for your infrastructure to be supported, I would probably state you need a certain level of slack and reservation space on those nodes set aside for this operation of your control plane.
Sure. I understand something, I understand that we may want to have a reservation for something super critical for the cluster, but I think one of the things that is missing here is that daemon set pods are not necessarily super critical. So for example, I may want to run a log rotation service or pod in my cluster on every node. But this log rotation mechanism does not have to run all the time. I mean, if push comes to shove and I have to really remove something from my cluster to run my production service, I just remove the log rotation, and it's completely fine if I don't have any log rotations for a few hours, for example. So there are examples that maybe daemon set pods are not necessarily the highest priority pods in the cluster. And there are other reasons that daemon set pods may be rescheduled. For example, a daemon set which is critical may really have a lot of memory leaks that is eventually get killed by a kubelet. In that case, it's going to be restarted and it's going to be recreated, and we need to schedule it. And in the case of a cluster being under resource pressure, we may not have enough resources for it at the time that is being recreated. So we may need to do preemption.
But the preemption could occur on the kubelet side, right? Because the daemon set's pretty stupid. It just binds, right? There's not really scheduling. It just binds to all the things that match, right? And the matching is super dumb. So if it binds to the node, the kubelet can determine, like, hey, I'm bound to this. I'll try to run this thing. Either I have resources or I don't. If I don't have resources, evaluate priority, right? I don't know.
Kubelet doesn't, well, today, I guess, at least the admission controller of the kubelet doesn't care about priority at the admission time. So if the kubelet is using all of its resources and you assign something more to the kubelet will reject the new things, as far as I can tell.
It will still bind. The binding will still be there, but the kubelet will see and detect that the binding occurred on its watch. And on its list watcher, it can determine, it could do a priority evaluation, right? It says, like, I have no more resources. Somebody tried to bind me. It's the highest priority thing. I need to bump something else. And then I'll do a weight score there.
I think that was one of the proposals in the doc, right?
Yes, it's actually, I guess, Tim himself, or I guess, actually, Klaus also mentioned something like that, which is basically leaving the preemption to happen by the kubelet. That's a possibility, I would say. But are you saying this only for the case of daemon set pods, or for everything else in the cluster, basically all other pods in the cluster?
I'd have to think about it if it generically applies or not. But I'm specifically thinking about daemon sets, because if you keep daemon sets the way they are, as stupid as they are, this would be one exit. With regards to everything else, I don't know if you want regular scheduling to work that way. But you could, but it'd be inefficient, right? You would have, it's already inefficient, right? It'd be more inefficient.
It would be inefficient. That kubelet needs to replicate a lot of the scheduling logic to basically pick the right nodes, pick the right pods, and all of that. So which we don't probably want to go that way and have another sophisticated piece of logic in the kubelet to just determine which pods to pick. So That's a possibility. I don't think it's gonna resolve the problem though. So, so basically, what you're saying in this case, basically the proposal, if I understand it correctly, is that daemon set controller doesn't do preemption. Instead, it just doesn't care about availability of resources and sort of like blindly assigns pods to the nodes. And it's the responsibility of kubelet to remove some of the existing pods to make room for the daemon set pod.
If the priority is higher, yeah.
Yeah.
But I guess this might end up sometimes in loops, like where kubelet can never find resource for that daemon set pod, and daemon set pod keep assigning pod to that node.
The bindings don't go away typically, unless the kubelet, rejects
Like
it.
if the kubelet is rejecting that node or restarting, I mean, it might go into loop, like where daemon set is creating new pods. So
That is true. Yeah. Right.
If the binding, as long as the binding's not eliminated, the daemon set controller won't create new pods. So if the binding is there, it shouldn't. It will just wait. So like right now, if you have a daemon set controller and you have this weird event where like nodes come and go all the time, it doesn't care, right? It'll just like, they'll be bound. It doesn't do any checking.
yeah, okay.
No, wait. So I guess if kubelet rejects something, it will delete.
It will bounce. If it rejects, I mean, if you delete the binding, yes. But if you don't delete the binding, then it won't.
So basically, so in this, well, one obvious problem with the approach is that we need to do some, I would say, significant changes to the kubelet. First of all, it has to distinguish between daemon set pods and other pods. I think, no.
It would just need the priority value of the pod.
Okay, so yeah, we get back to that same point, whether we want to do it for all the pods or only for daemon set pods, basically. So for all the pods, let's say, for all the pods, if the pod priority is higher, then we need to have some logic for the kubelet to choose the smallest set of pods to remove to create enough room for this new pod. And by the way, there is also another problem, I think.
I think.
Yeah. So
yeah, please go ahead. Go ahead.
Yeah, if the pod has more sophisticated more sophisticated constraints, daemon set controller still needs to have all the logic to determine whether a particular node can ever run on that pod. Otherwise, we will get to the same situation or similar situation that Avesh was saying. Basically, the daemon set controller assigns a pod to a kubelet. Kubelet may or may not remove some of the pods to create the room for this, and eventually realize that this is not gonna. I mean, basically, the node is not gonna be appropriate for this one. And
like, I think moving preemption from scheduler to kubelet, but kubelet does not have views for whole cluster. Because when scheduler is doing preemption, so maybe because I haven't read your design document yet. So what we are your design document is about just preemption logic to not having the daemon set controller, or it's about in general like to have scheduling for even for these daemon set pods to have in the default scheduler.
So, yeah, the document actually is has several solutions, but generally we want to address the problem of creating room for daemon set pods when the daemon set pods cannot be scheduled due to lack of resources or lack of available
Okay.
nodes.
Okay, one more thing I want to make it clear. So here we are discussing to have complete preemption logic moving from a scheduler to kubelet, or just part of that logic to move.
Well, part of the logic has to move, right? Like you have to have on the kubelet side, because people resource requests and limits are optional, right?
Yeah.
And you could potentially have some mishmash of different QoS tiers as it exists today. I don't know if we're going to get rid of that, which I hope we do. But you could have a mishmash of best effort pods running, which are abusing resources,
Yeah.
right? And you could have other ones that have, high level priority, and you need some level of evaluating. Besides the rudimentary logic that's there, some portion of the preemption logic is going to have to say, like, you're going to have to boot this guy off this node.
That's already there today, actually.
Yeah.
Kind of.
Eviction logic is like.
Have you looked at the kubelet?
No, I guess.
Yeah, they already have some sort of evictions, right? Based on some.
They do, yes. But
The eviction logic has priority now. So it works with priority now. So if the pods have priority, then it tries to remove some of these burstable or best effort pods that are exceeding their resource request, and their priority is lower than the other ones, the other exceeding ones.
Yeah.
So you have like the matching question, and then you have the eviction question. You don't get if you split this preemption into those two parts, the eviction problem still will always occur on the kubelet side.
Yeah.
But the matching question of whether or not to put the code in there to match at all, I'd have to think of the cases, the edge cases that fail.
We know for a fact that leaving preemption to a kubelet is not an option for generic pods. There has been problems with that, including the fact that after you assign a pod and because there is always a gap between the time that you start preemption until the resources become available, and this time is significant. It could be like minutes. In the meantime, maybe a higher priority pod arrives, and you want to override your previous decision. So binding a pod right away at the time of preemption to a node is not a good idea, because you may not want to keep that binding later on and before that pod is started. That's one of the problems. The other problem is we just talked about kubelet requires some duplication of logic. A third problem is that while that pod is assigned to the node, and while waiting for the node to get the resources, another pod may actually terminate in a different node, or a new node may be added by autoscaler. So more capacity becomes available in general, and you want to override that decision and not wait for the first node to get the resources. You want to assign the pod to a different node so that the startup time goes lower. So there are some of these decisions that we initially thought about, and we decided to now go with the preemption in the kubelet side. Some of those kind of applies to daemon set controller, but not quite, because in daemon set controller, we have a more one-to-one mapping between a node and a pod, or an instance of a daemon set. So that, yeah, exactly. So it's not necessarily one-to-one, but for, let's say, a set of appropriate nodes that the daemon set controller chooses, we know that we want to run one pod per node. So, and that node, basically we won't have the option of not running it on one of these selected nodes and running it somewhere else in the cluster, which makes some of these problems for generic scheduling or generic preemption of pods go away for daemon sets. But it's still some logic in the kubelet side to take care of this assignment and removal of the pods remain. I'm not so sure if that would be the right solution to go with, and actually it would require some of the node forks to be involved in the discussion. So one other thing that we were discussing with Brian is the fact that we want to support preemption among multiple schedulers. So if multiple schedulers do preemption, we still want to support that and not have any starvation issues or race conditions between the preempting schedulers. And in order to support that, we need to change the annotation that we use today for nominated node name to a field, and so that other schedulers become aware of this node selection that happens at the preemption time and respect that in their future scheduling decisions. Our own scheduler has to do the same. Basically, it has to monitor the nominated node name of pods and take those pods into account when making future decisions. The changes seem to be reasonably small for the default scheduler. I don't expect it to be huge, but it requires us to look at pods which are not scheduled by the default scheduler. For example, pods that have a particular scheduler name, and we currently ignore all of those if it's not default scheduler, but we need to actually look at those, and if their nominated node name is set, we need to take them into account and assume that they are running on the nodes nominated to run them. So that change we will make. But our eventual discussion with Brian was that he didn't have any strong opinion about how to move forward with supporting preemption in daemon set controller. Based on our conversation now and on some of the design ideas in the document, looks like we have 3 or 4 options. One, to leave it up to the kubelet to decide. 2, leave it to the default scheduler to schedule the daemon set pods and do the preemption for them. 3, daemon set controller does preemption, taints the node to avoid competition with the default or other schedulers. I guess the 4th idea is to just let the daemon set controller do the preemption and ignore this problem altogether and think that it's going to be rare and it's going to happen only in clusters under resource pressure. So these are the 4 ideas that I think I have in mind. Oh, well, there is, of course, one other one, which is actually make a daemon set controller more like a full-fledged scheduler with proper queues and running all the predicates, have its own cache and everything. That's another option.
I looked at Brian's argument too about like why, because right now we arbitrarily choose boundary lines for processes. Because if you look at the controller manager, it's basically just a lumping of all the other controllers together. Mm-hmm. And even in Borg, in the paper, right? Like you guys smash your controllers and your scheduler together for obvious efficiencies, right? So, and that's the way Mesos frameworks work, and that's the way a whole bunch of other things work, right? And that smashing the daemon set controller and stupefying it down so it just leverages pieces of the scheduler directly, and just in queues. I don't see why that isn't like a way to go forwards. And you could also have ordering of evaluation then too. So like if you could always order evaluation for daemon sets first, or whatever you cared about, right? Mm-hmm. But you could be much more explicit on how to evaluate things.
Right. So basically, you are suggesting to go with the sort of like fifth solution that I said, basically make the demand set controller more like a full-fledged scheduler, but it has some customization for the scheduling logic, right?
Well, I was thinking smashing it into the actual scheduler as a sub-element and gutting pieces of it. So it's like, it's much stupider than what it is today by leveraging the current parts of the scheduler, because it'd be just like the way the controller manager is. Controller manager spawns a bunch of routines. Each one of these routines is its own control loop, right? You could still have piece of what the daemon set controller does, but then coordinate that with how the caches are working, as well as the order of evaluation you want to do things in.
Tim, could you help my understanding a little bit? One of the proposals was that a daemon set controller creates pods with a node selector, for example, which would have the same effect as what you just described, but it sounds like there's maybe some difference in how you expect it to perform or behave.
Yeah.
I think it's performance as well as like what you're doing. Because if you, right now the daemon set doesn't have a lot of caches for pod history. It does for its separate thing, right? But there's special optimizations that occur inside the scheduler for how the caches work because of, you know, assuming that you know the bindings that are going to occur there as well as other data, right? So there's been a lot of history for how the caches evolve. So I'm just thinking, like, for optimization purposes as well as efficiency, you could just literally take that code, start a separate Go routine inside of the scheduler, and then trim down pieces of that, and then have a handoff between the scheduler and daemon set of when they need to do certain work, because you'd be leveraging the same caches. You'd have to have a pipeline of how you would evaluate things, but other than that, the pipeline already exists inside the controllers, right?
So in terms of separation of concerns and responsibilities, I don't think that bringing the daemon set controller into the scheduler is a good idea, really. And I will see some resistance in other SIGs. But what you're saying is kind of very similar to like solution number one, apart from the fact that you are saying that we bring the code to the scheduler, or sort of like running it as a scheduler process, as a part of a scheduler process. I don't think, I don't feel really great about that architecture, because now we are bringing one of the controllers which doesn't really belong to the scheduler inside the scheduler, and we have an alternative solution for that. Just Jonathan said, and that document also says, which is daemon set controller sets these node affinity for the nodes and then leave them up to the scheduler to schedule them, which is potentially achieves the same goals, I believe. Okay.
The biggest benefit for the daemon set controller right now that I use it for is bootstrapping the control plane, right? And so the daemon set controller is order literally one operation, right? Because it's blind. It's basically order nodes, right? So and it goes super fast, and you can bring up a control plane of 1,000 nodes in relatively short order, because it binds the pods directly. It literally does 2 passes and then it's done.
Right.
And if we do it this way, it'd be much slower to bring up a cluster of size n, because of how the scheduler operates and the limits that are put in place on purpose. Or the limits originally put in place on purpose, because we'd blow up the system if we didn't have those limits. But now some of those limits are fictitious. So if you did this, the consequence of doing that would be that a lot of the bootstrapping issues or startup conditions that occur would be delayed a lot, right?
Unless you optimize it. So for that particular thing, if performance is a concern, the Borg scheduler actually has a decision path that short circuits. It has awareness of some of the constraints and it short circuits a lot of that logic just to optimize that one case. for a totally different reason, Borg has this weird nested scheduling model where it needed to do that kind of optimization routinely. But that could also be done. So I don't think that specific thing is that compelling one way or another as a reason.
So, but generally, when we talk about performance, we should quantify how much it is. For cluster bring up, I would not expect like running 100 daemon sub pods or scheduling 100 daemon sub pods in like nodes with like 100 or several hundred nodes to be really that slow. I wouldn't expect it to be especially if you don't need to do preemption when the cluster bring up is concerned, and we don't need to do a lot of checks for finding nodes, appropriate nodes. Probably you can easily find nodes to run these daemon sets, especially since we have node affinity for them that is set by the daemon set controller. Our search is pretty limited, so I don't expect really a whole lot of performance issues in cluster bootstrapping. So to give you a little bit of context, Tim was suggesting that maybe we should bring the whole like daemon set control logic into like scheduler. And
yeah, I saw that proposal.
Yeah,
I'm not super fond of that.
Yeah,
similar to the fast path you were describing, though.
Well, no. So the daemon sets controller today, the most complex parts of it have to do with rolling updates.
Mm-hmm.
And the reason it's owned by the workloads team, who's also building deployment and stateful set, is because it's very, very similar to stateful set in terms of the semantics and the implementation. And in terms of how users use it, there's also some overlap. I mean, yes, the original intent was to use it to manage node agents, effectively control plane components or extensions. And actually, there's a lot of unexploited opportunities in that area to make that work better for a cluster lifecycle by more tightly coordinating node lifecycle and the daemon lifecycle. So I do want to make sure we don't lose that, but I don't think it makes sense to bring in a lot of the whole daemon set controller, the set of people who are actually building that controller. I think it makes sense for it to be the same set of people who are building stateful set, for example. So, in terms of the scheduling logic part, however, whatever amount of that needs to be in the daemon set controller, yeah, I mean, that part definitely makes sense to be the scheduling SIG to be involved with that.
Okay.
And I made this comment on the document you discussed earlier. The daemon set at least needs to evaluate the attributes for selecting the nodes where the daemon should be run in order to decide what pod to create. And that's true regardless, and is broken today and needs to be fixed regardless of everything else.
That's incomplete. That definitely.
So did you talk about the why we support multiple schedulers?
A little bit, right. So, and I told them the plan that we need to keep supporting it for now, at least I think, and we need to support multiple scheduler doing preemption and adding the field and the awareness for other schedulers. So that part is something that we are going to do. The main debate right now is that how should we proceed with like daemon set controller scheduling logic, and whether we should like let the main scheduler do the preemption and the scheduling of the daemon set pods. Still, we expect those pods to be created and the nodes to be selected by the daemon set controller in the form of node affinity, for example. And I think the idea, if Tim agrees, the idea of integrating DS controller logic into scheduler is not going to be, I think, a great solution for going forward.
Yeah, I mean, again, there was a little bit of, I don't know, spitballing on that idea. I understand the constraints behind that, and they're both technological as well as logistical. And I respect the logistical ones even more than the technical ones, right?
Yeah. So yeah, so back to our possible solutions. As I said, one is to leave it up to the scheduler to do the preemption and actual placement, the final placement, basically. That would require some changes to the bootstrapping, like making a scheduler or default scheduler a part of cluster bring up.
So does that potentially break existing cluster bootstrapping tools?
Not what it could. I don't know. I don't know if other people have implicit ordering. From KubeADM perspective, it does not. The only thing we require is the API server has to be first. Other than that, nothing else matters. Because
Probably not. I'd be surprised if we face any major technical problems there.
It would have to be someone who starts the controller manager, but not the scheduler, which actually broke everybody when we first broke out. Scheduler was originally in controller manager. So we broke everybody when we pulled it out. But the reason we pulled it out is to make it pluggable. So I think
it won't break people, at least not today.
Okay.
It's so long as that it comes online to be able to, you're gonna have this weird ordering on startup that'll be different, right? Because you're gonna have the controller manager, or you're gonna have the controller manager for the daemon sets basically in queue for the scheduler with some extra selector, the information that it has, and then the scheduler to schedule, right?
Yeah.
And there's also no guarantee that a cluster is running the default scheduler, although it seems like a rare scenario.
So
we have at least 4 examples, right?
But some of them actually run another scheduler alongside the default scheduler.
I see.
But going forward, we can tell them either you need to take care of those daemon set pods as well, or run default scheduler in your cluster.
So is it possible to reach out to them? There aren't that many of them, right?
Right. And then, those that we know, not that many.
Yeah.
So any objections to this idea of basically letting the daemon set controller do pretty much what it does today and select the appropriate nodes for a particular daemon set and creating pods for those nodes upfront, setting the node affinity for those pods, and leave those nodes to the default scheduler to run those pods, or basically find those pods.
It's I'm not terribly opposed to it. I think this was actually the original idea a long time ago, actually.
Yeah, I'm the one who has opposed it in the past. And I do think, we discussed some things that we have to do regardless to fix the behavior. I think we also need to document the scenarios we want to support in terms of scheduler pluggability and multiple schedulers to make sure that we preserve that and discuss how we can test that. Because clearly we've done some things when we added the new flavors of affinity, and when adding preemption, we have done things that have broken other schedulers. Like it is not possible for someone else to actually run another scheduler correctly in the presence of these features. So we need to address that if we are going to continue to support the use cases that we wanted to support by supporting multiple schedulers. And then, just writing a document about how we expect what the division of responsibility should be and how all these control loops should interact, right? We have the scheduler and the daemon set controller and other controllers and kubelets and all of the 4 flavors of autoscaling and descheduler, right? So it's going to become very confusing. Borg had at least 6 different control loops as well. and you end up with pathological interactions if it's not clear to everyone, or you end up with things being done in an unfortunate place, like things being done in the template that should not, or things being done in the scheduler that should not.
This is why I wanted to make this is why in the original document, even going back a long time ago, the librarification or SDKifying the scheduler such that, it's really easy for people to build their own just by making well-defined pluggable layers that would automatically include these other logic pieces that we create.
Yeah, so I think that proposal, the scheduler as a framework or platform or whatever proposal, is an important component of this, of the strategy going forward. And also, we had talked about creating a way to automatically change the default for some set of pods, either at a namespace level or some other way. That was never implemented. I think that could potentially go a long way. So one challenge we have is for hosted solutions, like if you look at GKE or Azure or EKS or any other hosted solution, I guess there are others, the user doesn't have the option of disabling the default scheduler. So then they can't, or they also cannot add the extensions, right? They don't have access to the configuration mechanism or the execution mechanism that would allow them to add the extensions they need. So that, I think, has to be, if our goal is to allow these extensions to be implemented, then there has to be a way to achieve that for this kind of a platform. And one way with the scheduler as a framework proposal would be they would reuse all of the scheduler code maybe, but they would run another instance and then delegate all their pods to use that scheduler, right? So in practice, there wouldn't be competing schedulers, which I think is the dominant case where people want to run their own scheduler, is they have a particular set of extensions for all the nodes, or they have a very specific thing they want done for a specific set of nodes, or nodes with a particular type of resource, or a particular flavor of pods that doesn't interfere with the others. Like running daemons at the highest priority doesn't really compete with the others. Yes, it should be able to preempt the others, but it doesn't really compete with them. Or best effort pods, which aren't affected by the normal request-based scheduling at all directly, right? If they just use usage, for example, to do best effort scheduling, that's using a totally different set of criteria and information for deciding if they fit, right? Those are really the cases where we knew we weren't going to spend effort on that for a long time, but we didn't want to prevent other people from implementing that.
Those are all valid cases we need to address, and hopefully with our proposal, we're going to make it easier for others to hopefully build those kind of schedulers, and we're going to keep supporting multiple schedulers. At least today, we don't see any reason why we shouldn't. But maybe we may want to convey this message clearly to people that running the default scheduler is necessary for bootstrapping, or you have to replace it with another scheduler that can take care of the scheduling set pods at bootstrap.
Yeah, so that needs to be, we need to take that message to the cluster lifecycle SIG.
Okay.
I'm here.
Unfortunately, don't have time to go to those meetings anymore.
So we're running out of time. Avish, you had one item on your on the agenda. That's a quick thing. You can bring it up. Otherwise, we can postpone it to the next meeting.
Yeah, I mean, it's kind of a very small issue.
Yeah.
Like right now, the balancing algorithm we have, we just consider CPU and memory, and we don't consider PVCs, because also PVCs are not initially bound to nodes, but still PVCs have limits. Like if you see in AWS, I think there is sort of limit 40 per node.
Right.
So when we are doing this balancing, it might be skewed with respect to PVCs, where we have some nodes where we have capacity for CPU and memory, but we don't have capacity for PVCs, and on the other way around, we have capacity, we are out of capacity for PVCs, but we have capacity for CPU and memory. Right. So just to consider that into your CPU and memory balancing algorithm.
That sounds good, but to make things clear, I think we are not talking about PVCs particularly. We are talking about balancing the number of volumes attached to nodes.
Right.
Yeah, because the confusion was there. PVC is not quite attached to any node.
Yeah.
It's the
I mean-
PVs that are attached, but it's not
Yeah.
ones that are explicitly represented. You can also have other volume sources still.
Yeah.
Basically, we need to add this priority function that balances the pods or spread the pods based on the number of volumes attached to the nodes. And that's a valid use case, I think.
Yeah. So one thing was either like we can do that as part of existing balancing algorithm, or maybe we can have a separate new function for balancing. I mean, like whatever like we agree upon, we can do that way.
It's similar to other priorities.
There are going to be other
right?
resources like GPUs and other things, so I wouldn't create a separate one for every kind of resource.
Yeah. Probably we should just come up with maybe a generic method
Okay.
for doing.
Yeah. So just wanted to bring it up so that like we agree, like we want to go ahead with that. Yeah.
Sure. Yes.
It might not be like a very big implementation, maybe some small implementation.
Sure.
Yeah. Thank you.
I guess we're out of time.
Yeah.
I'm not so sure if there are other people on the call, so I guess we can end this meeting.
Thank you.
Thank you.
Bye-bye.
Bye.